Welcome to Praveen Patil, College of Diploma Engineering and Technology. Myself Raj Gheware, working as a lecturer in Mechanical Department. We are looking on the subject Theory of Machine. We have started with chapter number 3, Camp and Follower. So, in this chapter, we have discussed on camp and follower various types. Along with that, we have discussed on camp terminology. Also, we have seen various motions of the follower. So in this classification of camp was remaining. So we will be looking on wedge camp. So over here a camp has translatory motion and the profile of the camp is formed on one side of the camp as shown in the figure. Here the wedge camp has a wedge of specific counter. The translation motion of the wedge is impact to the follower, which either reciprocate or oscillate. Generally, the spring is used to maintain contact between the follower and the camp. Let's see about the radial or disc camp. In this type, as we are able to see in the figure, in the radial camp, the working surface of the camp is designed such that the follower moves in a plane perpendicular to the axis of the camp, performing reciprocity or oscillating motion. The camp made out of a plate in surface, a way that the follower moves radially from the center of the rotation is known as a plate camp. This camp are also known as disc camp or radial camp because the surface of the camp is so shaped that the follower oscillates in a plane at right angle to the axis of the camp. The most common is a plate camp. For this reason, we shall strike out discuss on the plate camp, although the concept present particularly universal. So here in this, we will be discussing on the problems of the camp and the follower, and the rest other part how we can draw it in the drawing sheet. We will be discussing in the practical part. So let's go to the an overview and let's see how the drawing of the camp profile has been made. So before we proceed, we will discuss on the cylindrical camp. So in this type of a camp, the follower are either reciprocate or oscillate in a plane parallel to the axis of the camp, as we are able to see in the figure. A circumferential counter is cut out on the surface of cylinder which rotates about its axis. So this camp is also known as circular camp, that is nothing but drum or barrel camp. So let's see on one problem about the camp and follower. So I will just read out the question. A camp is to be designed for a knife edge follower with the following data. Camp lift, that means cap is lifting upward, so its distance is provided, that is 40 mm during 90 degree of camp rotation with simple harmonic motion. So here SHM motion is provided to us, so we have to draw displacement diagram with SHM method. Second is dwell of the next 30 degree. During the next 60 degree of a camp rotation, the follower returns to its original position with simple harmonic motion. Next is a dwell during the remaining 180 degree. So we have to draw the profile of the camp. So before we proceed, we will first of all write the given data. So S stands for the stroke, how much is the distance into which the camp is been lifted up. The follower is been lifted up. So here it is given as 40, so we will be converting into meter, so that is 0.4 m, and outstroke angle is given as 90 degree. So we will represent in terms of radian, it is represent like this, Return stroke is also given as 60 degree. So it rotates at RPM of 240, n equals to 240. So this is a displacement diagram. So let's see how we can construct a displacement diagram. So we have to take a scale. So if let's just say we are taking 1 centimeter equals to 20 degree. So from this A point to X point, the total distance will be 18. That is for 360 degree. Now, once we draw this line, we have to represent for the outstroke. So here outstroke is given as 90 degree. So based on the scale from A to S, that is from A to S, this we will be taking it as a outstroke. And there is a dwell. So dwell, this is the part of the dwell which we have indicated. Dwell is for the next 30 degree. So it is represented over here, next 30 degree. Dwell for next 30 degree. After this, there is a return stroke which is at an angle of 60 degree. So this is the return stroke which is at an angle of 60 degree, and there is a remaining dwell of 180 degree. So what I will do is I will just write down all the angles of return stroke as well as of other. So here, so the first one is of outstroke which is at an angle of 90 degree. Then there is a dwell of 30 degree. Once again return stroke is 60 degree, and after that there is a remaining dwell of 180 degree. So according to the scale we will be constructing a line, and we will indicate outstroke, dwell, return stroke, and the last dwell. Now once we construct this, as we know this is a simple harmonic motion displacement diagram. So for this, how we can construct is, first of all we will create a block. Now in this there is a stroke is given as 40. So here we will take this as a 40 based on the scale. If you are taking 1 centimeter equals to 10 mm, then 4 centimeter will be the length of this line. Now once we take this, we will take the center point, and from the center point we will draw this semicircle like this. So once the semicircle is drawn, we will divide this semicircle, and when we divide this semicircle, we will represent each point on the semicircle, that is A, B, C, D, E. These are the divisions on this semicircle. After doing the divisions, we will extend the points like this for E, D, C, B and A. Once we extend this point, we will also divide this outstroke, that is from A point to S point, into equal number of division, and we will represent it as a point as 1, 2, 3, 4, 5 and 6. So what will happen over here is, we will extend these points 1, 2, 3, 4, 5 and 6 in upward direction. So what will result over here is, we will be getting intersect point from this horizontal line coming and to this vertical line coming from here. So we will represent that we will mark that intersect point, and once we mark that intersect point, we will represent it with letters, like we are represented over here with letter as capital letters A, B, C, D, E, F and till G for outstroke. So we will join this points which we have achieved, and we will get a smooth curve like this. So once again same procedure which we have to follow for the return stroke. Once again here return stroke over here, return stroke, the angle of return stroke is 60 degree. So from here to here we have taken as 60 degree, that means 3 centimeter. Now we will divide this into equal number of 6 equal divisions, and we will draw a line. We will extend this line upward. So once we extend this line upward, same way we have to extend this E point further to this point like this way. So what will happen is, when we are extending this point, the line which is coming in vertical as well as in horizontal direction, we are getting some intersect points. So these intersect points are nothing but H, J, K, L, M and N, and the last is P point. So we will join this and we will get another smooth curve. So at the end we will be joining all these lines. So this is what the profile of displacement diagram is constructed. Now to construct this part, the profile of camp with the line of stroke of the follower passes through the axis of the camp shaft. Now in this, what we are going to do is we will be constructing this as the circle. Okay, so in this circle, based on the radius, we will be constructing, that is stroke of 40 mm is the radius. So once we construct this, from A point to S point is the outstroke, S to R is the dwell. I will represent it over here. A to S is the outstroke, then further S to R is the dwell, R to P is the return stroke, and the remaining dwell, that is S to P, is the remaining dwell present over here. So regarding this, the construction of this profile we will be seeing in the practical part. We will be looking at in the drawing sheet how we can exactly construct this profile of the camp. Also we will be discussing on when there is a off, where we will be discussing on the problems of the offset, when the follower is offset at particular distance, how we can draw the profile of that. We will be discussing in the practical, where we will be drawing the profiles of displacement diagram as well as the profile of the camp. So that's all for today's. We will be today topic. We will be stopping over here. Thank you.